I think we can get started. Welcome to the DMM working group. This is the working group session. So today, couple of things. My co-chair Depeng is not here, and this is Sri Gandavalli from Cisco. And our AD Suresh should be joining anytime, but we can get started. So a couple of things. This meeting is governed under some IETF rules and regulations. These are captured in various IETF specifications. Please be aware of that regarding IPR policy and with respect to what you say, right? Please be mindful of that. And before the meeting, I think blue sheets, I'm waiting for Stephanie. We don't have the blue sheets yet. But maybe we can, yeah, I didn't, I asked one of the guy, he said he'll ping. I think she's in a meeting, but it's fine. So welcome, Suresh. And minute takers, I think, right? Yeah, Sadar-san and Pablo. And just some background, the deadline for the slides was Saturday. And surprisingly, they sent the slides on Saturday morning, but they put IETF 102. That threw them back to the next day, and they won the award for the note takers. So thank you, Sato-san. Thank you, Pablo. And so a couple of things. I think the status of the various working group documents. I think the first thing is on-demand mobility document. This, as you remember, this cleared the IETF last call, and it also cleared. It went to pretty much it's on the AD review now, not IETF last call. Sorry, the working group last call, but it's on the AD, and there were few reviews that the authors worked with the reviewers, IESG reviewers, not IESG, but IESG assigned maybe expert reviewers.
Director reviews.
Yeah, director's review. That they cleared it, but a couple of things. Yeah, I think, yes, Suresh.
Yeah, Suresh Krishnan, responsibility for this. So one of the things like that personally, like I got private comments about was like, the consensus in the working group on this is not very clear because there didn't seem to be much support, at least on the mailing list. And so one of the things like I thought would be useful was like, get some kind of implementation commitments because we spoke to Danny, like Sri and I spoke to the lead author, and he said like, somebody's considering implementing it. So that would have been like a nice way to show it. Right. I also thought of like an alternate way of doing that would be to do like a quick check on the mailing list saying like, hey, like, are you interested in this progressing? And that would be like, I would think fine with me too. So I don't mind sending a mail to the mailing list. If like that's fine with you, I'll just send a note saying, hey, are you interested in this draft progressing? Because I do want to see like a trail of like people who are interested in this progressing outside the author set really. And that's pretty much it. So I don't think like, just a commitment from OS vendor is something that's required right now, but I want some kind of interest. And I also had another chat with like the authors, like one of the things in IETF we haven't done. Okay, so we used to do this a long time ago, but we don't do socket interface stuff. Okay, and this came up in Interia yesterday as well. And so the actual C socket API definitions are being done by POSIX, not by us. Okay, so like so another thing that probably needs to get done here is like make it a bit more generic, take out the hash include net like stuff and things like that, right? So those things probably have to get ironed out a little bit. So Danny, are you here?
Danny is not here, I believe. Yeah,
that's fine. So I think we know how to go forward from there.
Okay, that helps, Suresh. Thank you for that update. Yeah, Charlie.
Charlie Perkins. Yeah, if we can't use sockets, is there some genericized API that's approved by the ISG? Do we just use function names, paren, parameters, close paren, and then we can make some magic statement about typical include files are to be used? Okay.
Yeah, so like again, this has come up as a design pattern in multiple places, which didn't work, right? We did the MIF API, didn't get through, right? Like PVD, MIF PVD API didn't get through, and so on. And the one thing we know, like for sure works, I think is the GSS API. So I think we can probably get inspired by that. Like that's
Yeah, that's
kind of
great
like
example.
a successful
Right.
example there.
I think fair. I think I agree with what you said, Suresh. Only thing I want to be a little bit sensitive is the amount of time the authors have invested, because I think there is I want this, because it's so late in the game. I want to be a little bit sensitive on that aspect, because there's a element of frustration there that I think we should address that properly.
Yeah, Suresh again. So I think that's a fair point, right? And I really think we should. I know this thing came during the chair transition, so like I think it's kind of slipped in between. But I would have really expected like this decision to be done like much further ahead. I think in December 2016. So this document was working group last called in December 2016.
Right.
Okay, so it's almost 2 years since the document finished working group last call. So that's really I would have said like, okay, at that point decide like to take this forward or not. Like, and I do think I understand the sensitivity.
Right.
Absolutely.
Yeah, I definitely on the socket thing. Even normally on a good day, I would have definitely. I don't have progressed this, but it's not my decision. Yeah. So I think we have a way forward on that. Let's see how those discussions go. Now, next, going to the deployment models. This is one. I think I was one of the co-author on this, but for this came out much earlier, but we are not seeing much value in this, and I mentioned in IETF 1 or 2, and I don't think it brings any value to the industry or to anybody at this point to progress that document. So therefore, as an author and also as a chair, I thought withdrawal is the right thing. I've notified the co-author, and I think this was also notified in the previous IETF, but just to be for the process to be completed, we'll close it formally, and we'll remove it from this thing. Now, on the next one is SRv6 for mobile user plane. I think good work is going in, but again, a couple of things. I think 2 things. The discussions are still light. Maybe it's still more reviews are needed. That is one thing. I think offline conversation authors wanted to include end marker support, but I think to eliminate any feature creep on this, I want to be extremely careful here, not to we are okay with additional documents, but not bloat this document. But that's my view. But we should take
one of course. I agree that the end marker mentioned in this draft make kind of the lengthy text and complexity. But
Absolutely.
I think it would be good to have another document
right.
to describe end marker.
Right. Yeah, because end marker has so many configurations like S gateway relocation, all of those modes to complete that. This is impossible to capture this in this document. So I think that's one thing. But in general, Satoru-san, when do you think we'll be able to? I know you have a presentation, but just quick word. What's the timeline looking like? Because for closing this work.
I'll mention later, but let me explain a little bit. I think it will be almost done in main part. So I think we need to improve the clarity and readability. So I think it would be less of a big part. So I don't think we need much more time.
So you think this needs to be run through Spring Working Group as well, or you think we are not need? Okay, all right. Okay, other thing.
Suresh Krishnan, so as AD, no, it doesn't need to run through, but I think we'll get a routing director review at some point in the process. But I kind of want like a little bit more review in the working group. So I think it'll be good, Sri, if we can take some names of people today, like who volunteered to do this before, like, you go to working group last call on that.
Sure. Okay. The next one is PMV6. There is Carlos. Yeah, Carlos. Any quick update, 1 minute update on this? I know your presentation, but still,
this is Carlos Bernardos. I will present later, but basically we have a couple of detailed reviews since last IETF.
Yeah.
So you mentioned there was a minor update. We did 2 updates based on the reviews that we have from Lail and from Danny. So there's been things going on.
Yeah, but no discussions on the mailer. I think this, before we officially, ask for reviewers, but I think at this point you guys need to solicit some reviewers and get some feedback.
Yeah,
I mean this is a new output at this point. Yeah.
I mean that we got 2 reviews that were posted on the mailing list. So I agree that we need more, but I mean that we actually got reviews.
Sure. Okay. All right. Maybe. Okay. And I think the FPC, we will talk about this. I think in general, authors believe it's in a completed state, but we'll talk about it. And finally, the anchoring, I think that's also, I think after Carlos rewrite, but pretty much, I think at least the document looks much better than before, but still it needs more reviews. I think finally, one previous work item, which is MNID document. I think it's ISG approved it. Now it's published as RFC 8371. Congratulations, Charlie. Right? It's probably, this was first published maybe like years and decades. Okay. All right. Yeah. So with that, I think we'll call for the first presentation, and I think it is. Okay, so, sorry about that. Yeah.
Hello everyone, Satoru Matsushima here. I bring some update on the SRBISC for mobile user plane, version number 03. I missed an IETF series number, so then I got the award of the note taker. Thank you very much. Yeah. So please next slide.
Turn it on, no? Oops.
Thank you. So here's a summary of the update from revision 2 to revision 3. So we defined the one argument as a part of the segment ID, which is called args.mob.session for the SRBISC mobile user plane that indicate the QFI and RQI and PDU session ID that's supplied as a seed argument. The QFI and RQI is defined in 3GPP document, but PDU session ID is actually not tied to the 3GPP specification, but in the context of 3GPP specification, we put TID, but it could still open to other mobile control plane protocol. So the seed may use the argument if required by UPF. So next one is modified end.map function. So previously we just defined this function to swap the seed, just only destination header. But this version includes the future if the mapped seed and SR policy include one or more SID in the SR policy. So the third is we added new terminology section for abbreviation and convention. So that makes people help to understand and to very SRBISC specific terminology and convention. So last thing that we added new terminology section for predefined SRBISC function. So it's also helpful to the people not aware of the SRBISC terminology and function. So that comes from the Spring document. So this is a brief snapshot of the argument of the args-mob session format. It is a 40-bit argument that you can see the QFI in the left, and the one bit is read out, and another bit is indicate. I'm sorry, one bit indicate RQI. One bit in bit 7 is undefined, and the rest 32-bit is to indicate PDU session. In the 3GPP context, it could be filled by TID. So next step, we need to extend function coverage, but as I talked before, the end marker will be good to describe in another document. And some idea already exists using orbit in the SR header, or we have the indicator of the SR end marker or other GTPU related message in the seed. And the other is, it will be nice to have, but if you can, it will be good if you have another concise example how to utilize SRv6 to the required user plane function. But I don't think it will be necessary to be in the document. So we did certain improvement in terms of clarity and readability. Thank you for Charlie. But I think we need more review from the working groups. So one of them is the anchor and anchoring clarification pointed out by Hanu, and the other would be have another more opinion. So please let us know.
So I'm Charlie Perkins. Could you put it back on the arg.mob session slide? Yeah, that. So I believe that it's useful to have TEID, and I understand why it would be handy to have that as part of the data available to the segment routing. But ARGs is a very, very general term, and it seems like to me that it would be better to find a more specific name for this. I mean, for instance, you could say this is the TEID.mob.session format or something like that, because that's really what it's about, is to put in the TEID, and sort of for convenience, you have the QFI so you can know how to handle the flow. And then there's a special meaning to the R bit that has to do with whether or not you can infer bidirectionality for the flow.
Mm-hmm.
Well, that kind of stuff is not obvious to people reading this document. And the way I found out about it was by plowing through some 3GPP stuff that wasn't cited. And so that's not a good situation. And I think it would be at least more expedient if we could find a name for this that was much, much more specific for its purpose.
Thank you. Yeah, the concept of this naming is come from the custom of the what SRv6 document already defined. So then we follow that custom. But yeah, I think a much more clear idea could improve the readability and help understand for the people.
Okay. Next question. Yeah.
This is Kentaro Ibisawa from Toyota ITC.
Say your name again, please.
Kentaro Ibisawa.
Thank you. Note takers.
Actually, I have two comments, and I sent two of them to the mailing list this week. One is that I think while trying to implement, I found that pseudocoding for NDM GTP4E is either inaccurate or hard to understand. And actually, I sent the one which I think correct. So if you could review it and update if it is inaccurate. And one more comment is that about t.m.tmap name. This function is translating IPv4 GTP to SRv6, which corresponds to NDM GTP6.d for IPv6 GTP. And if I'm not sure if there's any reason you did not put the GTP in the name, but if there is no reason, then I would suggest that we put GTP in the name to clarify that this is about GTP and not other type of tunnel.
Thank you. Thank you. I understand your opinion, and that exists kind of related to naming space. So yeah, I think we can improve.
Okay, thanks for that feedback. Let's make sure that we address that. Yeah. Okay, and any other? No,
Yeah.
no. Yeah.
Yeah, Suresh Krishnan. So one of the things I was concerned about is the SRH insertion stuff in the draft. As like, we had this really long conversation in 6-man, and I really don't want this draft to get ahead on that. Okay, so I have a couple of ways to resolve this. Okay, so one of them is put the header insertion as a precondition for this to go forward. There's a draft about header insertion, which is the draft wire header insertion, right?
But just to make sure I understand, Suresh, you're talking about the on-path, the discussion on on-path node inserting SRH.
Correct.
I thought they removed it by using a tunneling. Right now, it's
No,
no
the
longer.
draft still has stuff about
No.
SRH
As a
insertion.
very,
tunnel-
very special case.
Correct. So like, and it's a may in the draft, but it's in the draft. It says may,
Okay.
but it's in the
then
draft.
that-
Okay.
I see. What
So unless we know how to do this properly, I cannot progress this draft. Okay. So as I said, couple of ways forward, like either keep it out and add it in later and when that other thing happens, or just like I'll take care of the dependencies myself. So you keep this and let this go on, but I want a reference to draft wire in this, because this draft does not have a reference to draft wire. Okay, so just add that, and then I'll keep track of the dependencies myself. But and the other thing is, like, this thing has a strong dependency on SRv6 itself. That's one thing, and it has a dependency on draft FISFIS network programming, which is not even a working group draft anywhere. So there's like quite a bit of dependencies that are required. So I'm a bit worried, like, but what I wanted to say is, when you are ready, push it. Don't wait for the other things to happen. I'll make sure the other things happen before this progresses further. Okay.
Yeah. So I think the may part, I was not clear, but okay.
Yeah, the draft specifically says like you may turn on SRH insertion.
So I was under the impression it's only the in-cap mode now. Right now we are using the SRH, but if that is the case, we need to.
The draft says that. So that's why I did check. So it does say that. So just like make a decision. That's fine. Either way is fine. As long as it's consensus, I'm going to take this forward. But just remember that there's other dependencies on this.
Thank you. I think we can deal with those issues. So and also dependency, we can minimize the dependency to going forward the work. Thank you.
Thank you, Sadara-san. Now we want some reviewers. Actually, can you guys, like, who is can some of you volunteer to review this document, please? Okay. Okay. Please. Okay. Probably can get their names. Carlos and okay. Okay, and
Miyasaka-san, Takuya-san.
Thank you so much. Okay. Thank you, Sadara-san.
Thank you.
Yeah, I think. So an update on the distributed mobility anchoring. Yeah, I don't think it's working, but it's been turned on. Yeah, perfect.
Okay, so hi everyone, I'm Carlos Bernardos, and I will quickly review the state of distributed mobility anchoring draft. So The status of the draft, well, has been significantly updated in London. That was the main change for a while. And as I mentioned there, and as I mentioned in Montreal, we came from 46 pages to 15, and now we are in 17 pages. So we tried to reduce complexity and try to make the document simpler, because also the goals of the documents were not that complex. It was about introducing the distributed anchoring concept. So then in Montreal, we got, or after Montreal, pretty soon after Montreal, we got a detailed review by Lyle. Thanks for that. And we addressed the comments of that review. And as I will summarize later. And well, the draft is also available on GitHub for any one of you who want to take a look and also contribute there. So this is the overview of the current version. So basically, as I mentioned, we try to simplify a lot the content, and now it's basically everything around this describing the three main cases for the anchoring, which are the mobility case with traffic redirection, and the mobility case with anchor relocation, which is what I summarize on this slide. So basically, the mobility case is where there is no address continuity required. So basically, when you move, you change your IP address, and that's all. Then we have two mobility cases. One is the traffic redirection case. Well, basically, you need address continuity, and basically the way you achieve that is by getting the traffic from the previous anchor forwarded to the current anchor. And then there is, and you keep using the old IP address, of course. And then there is this additional case, which is called anchor relocation, where you require address continuity, but then you have real mobility of anchors, and it's a bit more complex, of course. So the three cases are documented with some generic diagrams, trying to use simple notation, and because the first versions were a bit heavy on the notation, and was hard to follow. So next steps, we believe that the document is stable, has gone through several detailed reviews, including the one from Lyle in the last cycle, and the one from Marco before. It was very helpful to try to simplify the document. This document has been there for a long time. So I honestly believe that is the moment to make it go forward, or basically will never happen. That's my honest opinion. So, of course, I'm open to get as many reviews as possible and to address the comments, but I honestly believe that we need to really go working group last call if we really want to move the document forward.
Right. Yeah, thanks, Carlos. I know it's been there for a while, but if you look at the last rewrite, it practically reset the whole thing, right? It was a significant rewrite.
Yeah, but that was in London, so we've been already a couple of reviews from people that computer right. So I think now it's simple to read. It should be, I mean, it's a very simple document. No high expectations on what this document is about. And I think that the energy is going in the group to other topics. So if we keep this thing there for a while, it will probably, I mean, nobody will care. So that's my main concern.
Sure. Let's close it soon, I think. From your point of view, you think this is technically, I think the technical correctness, you're absolutely sure there are no issues from it.
Yeah.
We'll get some reviews and get this going. Yeah.
Okay.
Yeah. Any questions? Yeah. So again, for this document, we need some reviews, and I think folks, can you please volunteer? We need help from the working group, otherwise we cannot progress documents. This is, I think we depend on the community. So yeah, Charlie Perkins and John, and we need one more reviewer, please, at least. Marco, okay. Marco, right? Yeah. Okay, cool, perfect, thanks. All right, anyone else? All right, thank you. This one? No, no. To the back. This one? Yeah, that's good. Okay.
Okay, so I'm Carlos Bernardos again, presenting the proximal APIs extensions for distributed mobility management. And this is okay, so this is the outline. I will quickly go through the story again and status, a very quick overview, and then next steps. If somebody wants details about the solution, there are some backup slides, but I think I will omit unless somebody wants to go into details. So this is the status and story of the draft. It was adopted as working group document after London. In the 0.1 version, we address all the comments that we received in the working group adoption call. Then in the 0.2 version that already happened since Montreal, we address a Lyle detailed review. And then in 0.3 version, which is the current one, we also address the Danny's comments. I will summarize the comments that we reviewed in the next slide. So quick overview. So the document is about a network-based solution for DMM based on PMIP. So basically we push the mobility management to the edge at the access router level. So instead of having one single anchor, we have multiple anchors for the data plane, and we have a one control plane entity. So we have a centralized control plane, which kind of LMA that is called CMD, and then a distributed data plane. So each access router where the mobile node can attach to become a MAG from the data plane point of view, and as an LMA for the data plane point of view for the addresses that the data access router delegates to the mobile node. So the mobile node, each time it attached to one of these distributed entities, it will obtain an IP prefix from that anchor, and it will remain getting continuity for the other addresses that it got on previous access routers. So that's why these distributed entities play the role of MAG and LMA for the data plane.
Okay.
So the changes since last IETF. So in 0.2 version that was basically addressing Lyle comments, we improved terminology based on his review. We added a lot of text on the registration. That was something that we didn't focus much or enough on the previous version. And we also added a lot of clarifying text. Then 0.3 version that was also based on a detailed review from Danny. We also did a lot of text improvement based on the suggestions from Danny, so thanks a lot for that. And we also tried to improve the way some procedures that were done with figures were described in the text. We have the figures, but the text accompanying the figures were not that as good as it should be, and we trying to improve that to improve reliability. So again, we believe that the document is stable. Of course, we will appreciate more reviews, but at this point, as from the author's point of view, we really need to get those reviews because we don't believe there is anything else remaining to be done, but to, of course, address any reviews that we may get.
Okay, thanks, Carlos. Can you talk about the implementation status?
Implementation status, well, we have an implementation for quite a long time ago because we actually shown that implementation twice in IETF, like 4 or 5 years ago, I don't remember. So implementation, there is implementation available, and we actually show it there. I don't remember in which IETFs. Was in Berlin, 2014, that was one of it, and the other one I don't remember. So there is code available, and there is publicly available on GitHub. So it's not it's a public implementation. So if people want to try, it's available.
Okay, so let's get some additional reviews. I think last time we asked for few reviewers, they signed up. I think we need fewer.
Last time we got 2 reviews, Danny and Lyle.
Yeah.
So
I think we need additional reviews on this, folks. Again, who can volunteer? Folks, yeah, John, thank you. Did Marco review? Marco review?
Not yet. I don't know if you want to be
Marco?
overloaded with more, but that would be appreciated, of course.
Marco is not even looking, I know. Okay. Okay, perfect. Yeah, thank you, Marco. All right. Yeah. Okay. Thanks, Carlos. I think, yeah. And I think, so Arashmit wanted to present remotely. So I don't know if, let's see if he can, I'll try if he's there. Otherwise, we'll need to. Oh, okay. Perfect. Okay. Pablo, that's a use case as well? Okay. Arashmit?
My name is Rashmid Akabain. I'm going to talk about.
Arashmit?
Yes.
Okay. Okay. Perfect. Yeah. Now you may have to repeat. I don't know if you said something. Yeah. Now we can see you.
All right. Excellent.
Okay.
Hi, everyone. My name is Rashmid Akabain. I'm going to talk about the demo that we put together for the SRv6 user plane removal core, based on the user mobility draft that Satoru-san and the rest have put together. Can we go to the next slide, please? The effort was put together, but the POC was put together as an effort by a few people around here. Chen, Pablo helped a lot to provide the base code for this, and Chen provide the actual implementation of the rest of the code that we put together, put the setup together, and during London and Montreal, I showed you the progression from existing GTP-based system to an SRv6 based system. The POC that we put together basically contains the first two steps in the set of the demos that we're going to put together as we go forward. Next, please. Yeah, so this is what we're going to cover. So the starting point for us is basically a set of SRv6 gateways, and the reason we chose this approach is to show that we can actually drop the SRv6 data plane in place of GTP without changing the control plane, 3GPP control plane. So this goes back to the mandate that 3GPP put forward, CT4 in 3GPP put forward, for us to only touch the data plane, and the control plane was out of the scope. And based on that, we picked up this approach to show that we can actually use SRv6 and smoothly migrate the existing GTP-based user plane to SRv6-based user plane. Next, please. Next set of slides. So I'm going to talk about, like, this is how things are going to work in the 5G. I don't have a 5G setup just yet, but if this was supposed to be done in the 5G network, we have an SMF up there that we're going to be using with the N4 interface to connect to UPFs, and then we're going to drop two SRv6 gateway right in the middle. The SRv6 gateway could be virtual, could be physical boxes, or at the end, they could actually get incorporated into the UPFs so that we don't need an actual virtual a box or another entity in the middle of the network. So the idea is basically to to pick up the GTP packet as they come in, pick up the source address, destination address, and the GTP tunnel ID, and pack them into the SID. And since in this particular scenario, and perhaps for a long while, we're going to have to deal only with 2 UPFs. Therefore, we will simply using the IPv6 destination address as our SID to send this information across the network. Once we get the packet on SR Gateway 2, then we pick up the destination address, we decode it into its original GTP format, and ship it to the UPF for processing. So the UPFs in this scenario will basically do not know that there is any SRv6 in the middle. The control plane in 3GPP remains intact, and this is simply changing the data plane without the control plane to satisfy 3GPP requirements. Next, please. So the idea basically applies to the LTE network as well, and this is what we used in our proof of concept. We have an eNode B, and we got a combined SPGW, and that's the link that we are showing. This is, of course, is N3 that I'm showing, not the N9. The reason for this is because we are using open source software that combines the SPGW, and we didn't want to spend too much time decoupling the service gateway from the packet gateway, and that's why we try to show the same type of work on the N3 interface, which is also applicable easily to N9. Again, the same idea, the GTP tunnel extends from eNode B to SPGW, and we do the same type of decoding as we did in 5G in 4G LTE network to accomplish the work. Next slide, please. So this is the setup that we are using. We are using OAI open source software along with VPP, modified version of the VPP SRv6 code. There is a USRP Ethos B200 with a phone that is connected to the system. We got a couple of Wireshark points that actually to show the packet trace, to actually show the conversion that happens right after the eNode B and right before the packets enter the second routing gateway. We use a physical box as our gateway, a virtual box as our second gateway, and the second VM, the third server, is a combination of service gateway, packet gateway, MME, and HSS. This is the bundle that we got from HSS, and I have a more elaborate version of this thing in my lab, but we didn't want to muck around with the OAI software packaging, and we basically took it as it was. Again, you will see that the packets actually arrive as a GTP tunnel packet to the first service gate to the first segment routing gateway, and then get translated across and then get decoded on the other side. Next, please. So a couple of screenshots that actually shows the ping to the internet. The far left basically is the outside of the eNode B. As you can see, the GTP tunnels that you highlighted, the information that is coming in, the source address, destination address. You got the UDP 2152 port, and then the TEID on one side. OAI on one side uses incremental TEIDs, and on the other side it uses the random number as a TEID, as I show you in the next slide. The middle guy basically is like the edge of the second segment routing packet. You see that we pack this information into the SID. We got the source address, destination address, and the TEID packed into the SID along with an IP prefix that is at the beginning of the SID. Coming out of the service SR Gateway 2 at the beginning of entering the packet gateway, the packet has been returned to its GTP format, and we process the packet at the UPF as if nothing really happened. So the UPF, the idea is that the UPFs will not see any control plane changes. Next slide, please. And this is the reverse traffic coming out from the SPGW going to the eNode B. As you can see, we are just doing the exact opposite. The TEID here is a bit more elaborate because, as I said, the OAI software basically randomizes the TEID on a way from service gateway to eNode B. But the process is identical. We basically send the GTP packet to SR gateway number 2, where it basically gets packed into the SID and shipped to the eNode B. By the time it gets to the eNode B on the other side, the packet basically has been modified to its GTP format by the SR gateway 1, and the eNode B basically receives a GTP packet. So I believe Chen is in the room. He probably right after this is going to go and set up the demo outside the room on a desk or something. We have a compact version of this demo that we can actually show to people who are interested. So I encourage people to go and have a look, and by all means provide us with comments. We need your comments to actually go forward with the next step. The next step of this demo will perhaps deal with a combined mixed IPv6 IPv4 equipments. Again, this is the first phase of migrating. The aim of this POC is to show the first phase of the migration path from the existing GTP-based system to an SRv6. The next step would be showing that, okay, so once we have done certain equipments, we'll turn to IPv6. We will perhaps will show a mixed IPv6, IPv4 network, and we show how things can actually interwork between the two domains.
Okay, outstanding. So very good. Any questions?
Yeah, serious question. So I have a couple of questions, right? So first one is the SR gateway 2 prefix. So do you assume that it's going to be a /32 prefix? Because like anything longer will not work, right? Because there's like 32-bit each IP addresses and then 32-bit TEID. So you need a /32 for every node that in the system, right?
Yes, for this particular GTP interworking, we have to actually set aside some space for the source address, destination address, and the TEID. So the rest can be basically is allocated to the prefix, which probably works for many of the networks right now.
Okay, and the second thing, I found it curious. You're swapping the addresses order. Is there any reason for that?
No, I just wanted to make sure that I'm following the draft user mobility draft, because there's an encoding in there that has been suggested. I'm following that basically.
Okay.
However, one quick point though, the structure of the SID, in generally speaking, the structure of the SID, we can suggest a structure in our drafts, and IETF can actually propose that thing. But I believe that at the end it's going to be 3GPP who's going to decide how this SID structure is going to be done. So what we do in IETF is suggestions to 3GPP. It would be probably changed once it gets to SID, it gets to the 3GPP, and they will decide how to restructure these things.
Okay. Third is I think the most important question. So what happens if you get a v6 GTP packet? Like if you have a v6 bearer on there and you get a v6 GTP packet?
Yeah, so that's what I'm saying. The next step of this demo is going to cover that, because we will getting the mixed IPv4 and IPv6 basically packet, and at that point the IPv6 will get an SRH. So the SRH with one SID will basically go in.
No, but how do you carry the TEID? Like, so all the things you put in there will be inside SID?
Yeah, if I'm using GTP inside IPv6, then of course I don't have enough room to actually do this. Then I have to actually create another SID within the SRH and carry it.
Okay, cool. Thanks.
Okay, very good. Any other questions? Okay, excellent. So Arashmit, what are the next steps? So your implementation will continue to spend investment time?
So we are planning actually to continue with this, and I have already received interest from several companies to actually work on this with us, and hopefully the next demo will be a collaboration between different companies, and we would have more names on the POC.
Okay, so I think it's good to document any issues that as part of this effort. I'm pretty sure your observations and all of that, right? Maybe one of these meetings will get, another meeting where you can present those issues or what are specific issues that you have.
Absolutely, yeah, sure.
Okay, Suresh Krishnan again. So what's the plan? Like, do you want to do any work in IETF for this, or do you just want to feed this back into Satoru-san's draft as like results? Because I see like a lot of work to be done here in 3GPP and not here. That's how I see it.
Yes, yes. So the idea is to basically closely tie this up with Satoru-san draft, and then take this to the next step, which is the 3GPP CT4, and basically create some momentum in there.
Okay, sounds good. Perfect. Thank you.
Yeah, that's what I'm thinking, Rashmit. I think it has to be more like a feedback. I think, I think whatever this investigation that we are doing, it can be a great input to 3GPP. So I
Yes.
think, yeah, mostly they're the final consumer and they're going to define the specification, but this
Exactly.
investigation has to go there. Yeah.
Yeah, that's why I was alluding to the fact that, yes, we can actually suggest all sort of structures into the SID, but I would like to actually, when we go to CT4, I want to mention that they are the one who are going to be having the final say in defining all these structures. We are just showing them the way. They will have the chance to actually standardize this the way they like it.
All right, Rashmit, time for sleep. Good night.
Thank you very much, Suresh. Thanks a lot. And again, the demo is outside, and we are preparing it for you guys to actually see if you're interested.
Sure. Thank you. All right. Next, we have the FPC update from Marco. I think so. A tremendous amount of efforts went into this document. I think, but from the chair's point of view, I think the situation is, something like this. We are not clear exactly, where we are. I think, Marco, please. Yeah.
It's about this slide. I'm very curious. So it mentions one chair. So I'm curious, is this you or the pink?
The pink.
So you're clear about it. So that helps a lot. So let me just, since slide cannot be here, just about recap and the status. So we went through 12 revisions. That's the version you find on the repository right now. We put quite some effort in making the core part clear, which describes the operation and information models. In the back, we still have the Young model. So since a while, we have Charlie on board who put some effort in making the core part clear. So it doesn't help if authors say it's ready for working group last call. So we want non-authors to understand what's written in the core part, and that's why we need reviewers. We got a light review from Carlos. Thanks a lot for that. We need a little bit more review on a deep dive on the information model. So if this is understandable, reasonable, so that kind of feedback would help us a lot to give green light to proceed.
Right. So I think one of the key burning questions seems to be about whether the Yang model should be separated out. What's your view on that, Marco? Yeah.
Sorry,
The Yang model should be separated out, or would that help in reviews? Or I'm trying to see, because anytime, it's hard to get reviewer commitment on a 100-page document. I think that's a fact, right? I think, yeah, it is a big document, right? I'm just thinking to really, for the time being, is it okay to break that, remove the Yang stuff, and maybe, at least get some
maybe we can
reviews?
separate this discussion.
Yeah.
I think it's orthogonal. So people getting this document will not start reading the Yang models. They want to start from the beginning to see what the document is about, what the solution does. So they start reading the core part. So I think separating or keeping the data model together with information model and operational description, that's a separate discussion.
Okay, fair point. Yeah. Charlie or Suresh?
Yeah, Suresh Krishnan. So I did do start reading the document already. I read it. So nothing really crazy in there. So I haven't done a critical review of the document, which I will when Sri pushes the button. But I think the document has improved quite a bit, from the last time I read it, and it is much bigger too. But I do think it's going to be challenging in IETF when it goes to IESG, because the larger the document, the larger the attack surface, and more comments people are going to have. And I don't have a good suggestion of trimming it down. Maybe Sri said, maybe this is something you can discuss with something, and probably then that separates out the expertise that somebody requires. But that's also a negative thing if you split it out, because the other person has to still read the non-Yang part anyway to understand the Yang part, right? So I'm pretty neutral on this. So if you want to keep this together or not. But right. I personally don't see any major issues in the document other than it not getting review. That's what worries me. I'll try to get another review outside the working group. Like when it hits me, I'll try to get a review on this. But and I'll send the AD eval, because I do have, like, I did have questions and everything. I'll put it in. But yeah, try to get some reviews in the working group.
So maybe I'm thinking this has a lot to do with policy. Like, maybe Dime guys might be like, good reviewers, right? You think, unfortunately, Jan is not there, but maybe somebody from some folks from Dime. What do you think?
Like it's a pretty quiet working group again.
I know.
Like it's really like, it's not like useful, but maybe I can push like a Yang doctor review or something, at least for that part, right? That's something we can probably try to shoot for, so that part gets done. But even the Yang doctor has to read the rest of the document. So it's not that they just check the Yang model, right? Because they need to understand the thing as well.
But in general, I think this document went through a lot of, I think, thanks to, Marco, Satoru-san, and Light and others,
Lyle as
right? I
well,
think
yeah.
tremendous amount of work. I think it's just that reviewers is, holding back.
Like we've seen this. This is like a common design pattern. Like, we saw L2SM, right? There's a document, people are just tired of the whole working group was tired, and they just managed to just get this past the finish line and died, right? That kind of level of thing, which was again like 150 something plus page document, right? So I want the working group to keep going, but like I want like people to review it too.
Right. No, fair point. Yeah, sure.
Just
Yeah.
a small comment here. So I think it's a good proposal to go also out of this working group and ask people with more policy background than mobility background to have a look at this.
Okay, thank you. Charlie?
I'm Charlie Perkins, and I really, really think we ought to split the document. And I think the reality would be that the non-Yang part would get done before the Yang part is done. And so we would get a solid architectural and information model done that could then be shown how the information model is applicable to PMIP and 3GPP architectures. Just the fact that the information model encompasses both of those shows the power of it, and also for instance, I mean, somebody might only be interested in the PMIP model for the Yang stuff, or only be interested in the 3GPP part. But anytime if somebody asks me to review a 150-page document, something inside of me is saying no, I'm not going to do that. But so that's already, maybe that's just me, but I think a lot of people feel that way.
Right. Fair point, Charlie. Yeah. Okay.
Yeah, so Krishnan, Charlie, stay here. So which of these two do you think should be canonical? Yeah.
I don't know what that means in this sentence.
Okay, so let's say we progress one thing and we start playing with the other thing, right? And it kind of gets out of sync.
Oh, no. I think clearly the Yang stuff would have to be considered to be subordinate to the main part of the document.
Mhm.
Right?
That's one way to look at it. The other way could be like one of them is more precise, right? So, so as I said, like that's kind of the issue, right? Like, so Suresh again. So somebody could easily consider the other way, saying the Yang is more precise, so it should be the final definition. That's what I'm saying. That's something to be considered too, right? I'm not taking a position one way or another, but that's something the working group needs to decide.
Has that happened in any other working group, that they would have the Yang stuff before they decided what the information model was?
No, like usually it's together, right? Like, and if it becomes big, then it becomes difficult, like you say, right? But if you split it up and then they get desynced somehow, right?
I don't see why they would be. I don't see why they would lose synchronization, because
You said the Yang is not
nobody
done.
would work on the Yang model unless they cared about the information model in the first place.
Okay. Maybe I think let's get some feedback from Benoit as well. Benoit might have some. Yeah. All right. Thank you. I think we'll discuss with authors and Depang AD, and we'll move forward on that. Next one is essentially Shunsuke-san, or yeah, that's fine. Yeah. Yeah, there's a user plane protocol and architectural analysis.
Good afternoon, everybody. I am Shunsuke Honma, NTT. I will report the update of user plane protocol and architecture analysis on CCPP 5G system. So, thank you very much for lively discussion on email list. We think the contents were improved by the discussion, I think.
Okay, next slide. Okay.
Next slide.
You can use this.
Okay. So firstly, I will explain the background of this work. So this work is related to user plane protocol study in CCPP CT4, and this is became liaison reply, part of liaison reply from DMM working group to CCPP CT4. And this document has mainly two motivations. First is unifying the understanding level of IETF to specifications and architecture of CCP 5G system. And second is showing to 3GPP that IETF has enough level about enough knowledge about 5G specifications, and our proposal have enough value to be considered. And in this work, we analyze the GTPU specification and architecture requirement of 5G user plane. And also we extracted some evaluation aspects from the user plane architecture requirements. So this is history of this document. We presented this work in both CCPP and IETF in the last July, and we updated this document twice since the last IETF meeting. So major major updates are listed in the following two slides. So in the first revision, we mainly modified the GPU observation based on the feedback from CCPP CT4 as LS out. So for example, GTPU is basically point-to-point tunneling protocol, but some implementation will behave as merge point-to-point protocol, tunneling protocol. Or there are no definition about the order of extension header, but the specification document describes a note to recommend putting QFI information at the first extension header, and we describe the note in the document. In the second revision, we reflected the feedback on the discussion on email list, mailing list. So, for example, we received a question about termination point of GTPU, so we described the concrete description about termination point of GTPU. GTPU is used on N3 interface between G node P and UPF, and N9 interface between different UPFs. Sorry, this slide has errata. This update provided at second revision, so version number should be 02. Please note that.
Okay.
And in the second revision, so we provided supplementary explanation about something. So, for example, regarding to IP connectivity, we described that in terms of wide coverage, IPv6 would be better, and we should consider how to interconnect with legacy networks. Or 5G system allowed to distribute UPFs and select the destination UPF flexibly. So it may be able to achieve optimizing routing like ID lock protocols. So, but the specific processes are not defined. So IDLog maybe proposed to the usage as a solution. Or we received a point that there are no summary about network slicing architecture, and we added the overview of network slicing architecture in 3GPP. So in 3GPP, slice is composed of fundamentally composed of SMF, LANs, UPFs, and DNS. But 3GPP focuses on just only mobility management, and so transport network or other external network out of scope of 3GPP study. So finally, I talk about the status and next steps. So we caught up feedback from both IETF and 3GPP, and we believe that we received enough feedback, and we would like to request working group adoption of this document.
Okay.
And it's just a question. I would like to confirm whether this document can be an information RFC. If so, we can polish this document, these contents more.
Right. Thank you, Shinsuke-san. That was a good update. So I think before we open up for the questions, I think, yeah, maybe Suresh.
Yeah, Suresh Krishnan. So the one, like, I'm fine with, like, adopting this if needed, but I just don't have a visibility into what's happening in 3GPP regarding this. So I kind of want some kind of official communication. So if Satoru-san is there, or if you're there, probably, like, get another LS out from there and probably get it on the dependency list. Because if 3GPP is going to make a decision based on this, I want to see it on the dependency list, the official dependency list that comes out from the work items in 3GPP. Okay, so I can talk to you too. We can talk to Gonzalo and Georg to make sure.
You're right. Georg?
Yeah, Georg.
Yeah.
So we can see, because it's not on there right now. So, like, we can do it, make sure that, like, 3GPP knows it and we know it. And Georg, you want to say something?
So was there any discussion, a study paper, or any contribution to 3GPP based on this?
Yeah, as far as I know, the creation of study item, study document is proceeded in 3GPP CT4. So it refers this document.
Right.
So
Okay.
I
Let's
just
see from
wanted,
Georg.
this is Georg Meyer, I'm the 3GPP liaison. Adding this to the study will not help you for the dependencies, because the dependencies are only for normative specifications. And so, I mean, it doesn't put any pressure from 3GPP side to IETF to progress this work, practically as long CT4 hasn't taken a decision which way to go. So on the other hand, of course, have to be careful how to phrase it, but I think there are some people in CT4 that are sometimes doubtful how far the work in IETF in general has progressed. So everything that gets working group adopted and sort of gets the indication that you're working on that and you're progressing that, makes the decisions in CT4, of course, easier, because they see there's real people behind it and there is also interest from IETF behind it. So from that perspective, not from the dependencies, but from the signal that you're sending towards 3GPP, it might be a good idea to adopt such work. Thanks.
Yeah, I think, thanks, Georg. I think that helps. A couple of things. I think from my point of view, I think the document is very well written. I think it's a good work, actually. I think it can be a good informational spec. I don't think it can, in my opinion, it should not be a standard spec rather, but that's needs to be discussed. But yeah, that's
right, Suresh Krishnan. So if I understand, okay, so now I have a better view after, like, Georg spoke, right? So then I have a different issue, right? So if the only use for this document is to guide the study item, what is the archival value of this document in the RFC series, right? Because once the 3GPP study item is done, then 3GPP just moves on, right? So who is this document useful for in the IETF? So that is like the second question. We can do this all during the working mailing list discussion, right? But that would be my question. So if it doesn't have value by itself to guide 3GPP, and 3GPP is not waiting on it, and they're doing their own evaluation, then I don't see the value in publishing this. I really see the value of this document, but not publishing it at RFC. So keep the document updated, like we can even adopt it as a working group item, keep it going, but then after the decision is made, we just drop it, right? That's kind of just setting the expectations right up front. Okay,
Yeah,
so
I think, Suresh, I think if you look at the IPv6 recommendations for 3GPP back then, 2005,
It's published.
it's published, right?
Yes.
I think there is archival value in my opinion, but I think
it's a
it depends
difference.
who the consumer is. Is it for IETF community? Is it for 3GPP community? I think.
I understand, but there's a difference, okay? So the document Sri is talking about is, I think, RFC 3314, okay? 3GPP asked us, okay, what is the prefix length you want to recommend? It's a clear question. We gave them an answer. It's 64. This one, 3GPP didn't come and ask us, hey, can you recommend as a protocol? If they did, that would be a different reference, like Georg said. Okay, so 3GPP is doing an independent evaluation. They're not asking us to do an evaluation. So do you understand the difference?
No, I think, but I think if you look at the analysis, finally you're not recommending one specific thing. Right? I think it's a that analysis is what the value is. It's not about a specific protocol recommendation, right? Yeah.
Yes.
I understand, but 3GPP is making the decision in the study item, right? So I'm saying this is very, very valuable. I don't have a question in that.
Right.
But if the decision is going to be made in a 3GPP study item, irrespective of what we write here, right? Then I don't see the value. That's what I'm trying to say. I don't know if what the dynamic is going to be going forward. But if 3GPP is not expecting us to give them like an analysis of like what's good or what's wrong and things like that, then I don't see the value.
So I think if you go back to the LS statements that we have received from 3GPP, so far they have talked about the work item, that's the study that's happening there.
Correct.
In general, they encouraged IETF to make progress on these work items. So based on that, I think we need to make a call whether this kind of work has value, whether is it just publishing a draft, is it good enough, or should we publish it as information RFC is one thing that the working group
That's fine. That's working group can decide. Like I'm not going to stop the working group from deciding, but I do see like a hard time justifying a publication of an RFC for this, especially since it has no archival value. So like one of the things, if you look at like, let's say the last 6 telechats, right? There's a lot of documents that have been sent back to working groups because they don't have archival value. Not that it doesn't have value. So one of them being an SCTP document, right? Which contains probably like 5 years of work of like things like clarifications and errors that have been discovered that got sent back to TSVWG recently because people didn't see the archival value of it. So like who will read this document in 5 years? That's the thinking, right? Period. Like, I'm not going to say anything more. So I'm not going to push something through the working group here. Working group can decide, but that's what I'm giving you up front, like
points,
how
fair
this
points.
is valued later. Okay.
I think let's, thank you, Sadara-san. Yeah.
Satoru Matsushima, 3GPP Hatton. I'm a reporter of the CT4 user plan protocol study. And I think that the document is very valuable for us because we already have input from IETF side, so all of the idea of the user plan protocol. So that I'm not sure whether the IETF is aware of the 3GPP architecture. So that the document shows the good level of understanding. So 3GPP, so that's good. But after that, I think it would be valuable if this document could be a good reference to introduce what's the 3GPP 5G architecture look like, and also the much deeper level of the GPU. So that would be the value.
Kiran, just a follow-up question. Will 3GPP ever refer to this document? Anybody can answer. Because it has archival value.
That's the only concern I have with this paper. I think you cannot assume that 3GPP will reference it, and you cannot assume that we will review it, right? So any content will be your content. It will not imply any changes in our architecture. It might be used as a guidance. That is fine. But I agree in that sense with Suresh that the guidance will mostly come from the study we are currently doing in CT4. Again, the CT4 study is not the whole business.
Right.
If CT4 agrees on something, that doesn't mean we will adopt it. There needs to be other working groups included in this discussion and so on, but you have a good chance then. So if this document is valuable for your own purposes, then I think you should go forward with it, and you should show that by some way of adoption or whatever. I'm not so familiar in detail with the processes, but please don't assume that from 3GPP side, we will reference back to that or will review it.
So maybe let me ask you a question, Georg. Would 3GPP object to IETF publishing this document? No, maybe let's hear from them. I think
Well, first, let's say, would anybody raise an eyebrow? Let's say it that way, right? We will not, and I don't think so. I mean, it's practically you doing here what we are doing in our study. So, yeah, fine, go ahead, and you need to know this. If it in the end should be an RFC, that's you have to decide, right? But this is nothing. We have nothing against you doing work, especially if it's 3GPP related. Thank you.
Thank you. Okay, Dave. Yeah.
So the 3GPP is not going to say no to anything. We can do like something which says like, should people live on Mars, and publish a draft, and 3GPP won't say anything. So that's not a good question to ask.
No,
okay?
I think
no, but it's not straight. Okay, so like I'm not going to go there. I'm going to like talk something to Satoru-san. Okay, so imagine I'm giving you like a completely crazy alternative scenario. Okay, so working group works on this, adopts the document, finishes the document. She does a working group last call. Everybody's happy with it. Okay, and then we take the text of this document, put it in a liaison statement, send it to 3GPP. Okay, that's option A. Other thing is we go through the RFC publication process. 7 months later, we have an RFC. Do you see a difference in value between these two? That's my question. Okay, I don't know what the answer is, but I want you to think of that question in mind, because that's what I'm trying to drive at.
I think with that logic, I think I'm not saying by the way this should be published or not. I think I think that's a separate discussion. I think, but I do want to highlight the fact that the work that we are doing here, this has some value, right? If you don't publish work, we can as well close down the working group. I think that's my viewpoint. I think in that sense, if a document has value, if the other SDO is going to use it, we rather publish it. Make sure the technical if they use it, absolutely. Yeah.
Okay. So, Dave Allen Erickson, I'm confused here. All of the discussions leading up to the liaison was they asked us for specific protocols we were working on. It was agreed that we were not going to send them analysis. We have a draft whose purpose is to attempt to say we understand this well enough that the analysis we provide is credible. We liaised it to them. My understanding, and based on some of the dialogue I saw, was they liaised back saying we didn't want analysis, but we are persisting. So what are we doing?
No, I think, Dave, clarification, right? I think what we said in the past was, we are not going to recommend one specific protocol and say that, this is the protocol that you need to use. We said that we are not going to go there.
But
what we said was, we are going to do technical evaluation. We are going to provide the technical feedback. That's what we said.
I'm kind of encountering this everywhere where somebody liaises asking a very specific question, which typically is like, what can we consume in the time frame of release 16 or whatever? And everybody's sending them the moon in response. And this to me just seems to be another example of it. I remember reading quite specifically the ask that CT4 liaised here. What we sent them back, I do not believe vaguely corresponded to it, and they called us on it. And we're persisting on going down this path. I don't think this is a good idea.
Okay, thank you. Final comment? Yeah.
Yeah, I'm a bit. It's a bit strange. You're mixing these two types of work so strongly up in your argumentation. I mean, we have the CT4 work, and that's rolling. And I mean, the only way you can interfere with that is that you make your technical drafts that are under evaluation, they're more stable. that I guess that's the one. Besides that, we might have liaison exchanges on certain dedicated issues. That's one thing. But this is your work. This is your own working group evaluation and so on. Why shouldn't you go on with that? What I don't understand is what's the relation of this to 3GPP that's all the time mentioned here, like impact to 3T4. I don't see that. I see that this is valuable work on standalone,
Right.
what you're doing.
Yeah, evaluation
Okay.
aspects.
I think that's a great comment. Yeah. Right. Right. I think we need to close down. Yeah, I think final comment.
Dave again.
Yeah.
Just very quickly, at the very beginning, the purpose of the draft was explicitly stated in the context of the relation to 3GPP. It was not a DMM work item. So
Okay.
if it's to
Thank
be
you.
useful for
Right.
DMM, and it's in the context of the IETF, they need to change the purpose they're advertising. Because right now it makes no sense.
Okay, thank you. Final comment. Yeah, we need to.
Satoru, yeah, I believe that the motivation of this work, it comes from the situation in the IETF. So we have a lot of the very interesting comment, whether someone said I couldn't read the Word document. I just see the text. We need text. I don't have a Microsoft license to read the Word document. So that's why we need to describe what the CGPP system looks like in the IETF manner.
Okay, thank you.
Thank you.
Thank you, Shinsuke-san. I think we'll. So, okay, how many? Just I think we are not going to issue the adoption call this time, Shinsuke-san. Okay. Next, Marco. This is a new draft that Marco Levish and Umberto published, and update on that. Yeah, draft. Yeah, please.
All right, so this is a new draft as re-announced, and it's actually complementing the discussion we had so far on the data plane protocols by applying the protocols on the table to apply to the N6 interface, which is a little bit under-specified in 3GPP, maybe for good reasons. So next slide. Can I?
You can, please. It's not perfect, but yeah.
Okay. All right. So briefly, background and motivation. So far, we discussed the new data plane protocols in the context of the liaison assessment with CD4, and the candidates are other tunneling protocols, ID lock separation protocols, locator rewrite protocols. So these protocols apply to the N9 interface. That's what the study is about, right? So everything in between the anchor user plane function and the actual data network, which uses the services, is assumed to be plane IPP that was being routed. Oh. Do I need to repeat? No. Okay.
No, you're good.
All right. So that's what the draft is about. So in the view of future use of a 5G network and in the view of efficient support for industry verticals, we see that there may be some demand for more flexible deployment options for customization and also taking some control on traffic steering and policing on that N6 interface. So what this draft is about, it enables decoupling of the anchor UPFs from the actual data networks for more flexible deployment and enable the control and enforcement of traffic steering policies on the N6 interface, in particular on transport network nodes which are associated with the data networks, and that's not being discussed in 3GPP. So can we adjust this one?
Oh, sorry.
So two brief use cases just to motivate this. So this is a deployment per today's 3GPP directions, and mobile applications may be associated and take services from distributed applications in distributed data centers. So 3GPP 5G control plane allows setting up multiple user plane function anchors, like you see here, to talk to the different data networks. So these UPFs get enforced traffic steering rules for uplink traffic to achieve that this traffic reaches the data networks on the right way. But there is no guarantee that downlink traffic happens in the same way. So there may be kind of misleading route taking the wrong UPF in case the two N6 paths are on the shared links. So we need some control on the downlink routes inside the data networks here to actually select the most suitable UPF for downlink traffic. That's one case. Another one is a little bit more dynamic in the view of applying. Let me just.
Oh, so,
That's your role, right?
I know it's much.
Just as one example, one case where we apply user plane function serving as a PDU session anchor to the very edge of the network, and just to support services in the edge cloud. Here you see a connected car scenario. So in addition, services running in the central cloud use this PDU session anchor on a long distance N6 interface. So in case the car, the user equipment in that case, moves, then maybe a relocation of a user plane anchor, maybe also aligned with the relocation of the actual service, just to keep the low latency kind of agreed service levels. And in that case, in case IP address continuity and PDU session continuity is required, we need to align the downlink routes in the different data anchors, data networks which use this user plane function in terms of downlink traffic routing. So we move actually the IP address being used by the device from a routable to a non-routable address. And here, segment routing, IGLOT protocols can be applied to route the traffic to the new anchor. So that's the second use case. The scope of this draft is that we first want to motivate this work by taking use cases, discussing the operation. Then second, propose an architecture that basically closes the gap between the policy enforcement points associated with the data networks, and provide an architecture a function of 3GPP as a binding element between this actually out of scope data network item and the 5G control plane. Because these downlink routes, not only routes, but also QS, whatever you need in terms of downlink traffic treatment policies, need to be aligned with the 5G system. So we need a binding element here. So the draft is about the architecture, how to bind the 5G control plane with the control of the downlink policies. Second is how to enforce these policies in the transport network of the data network. So FPC may be one candidate here, either discussion or specification or information level, or on the data models. The third thing is to see if 3GPP can expose on its control plane the required attributes and semantics to allow us enforcing the policies we need. So this is something which is treated orthogonal to what 3GPP does. If we came up with some attributes or some control elements that are required from the 5G control plane, we may end up in a proposal to 3GPP to extend whatever can be exposed from their interfaces, and that helps us to do that kind of policing of traffic. So the semantics and the data models for DPN traffic treatment policies on N6, that should be in scope of this draft. The current draft is a little bit focused on describing the problem, the scope. There is not too much on solution. We have some architecture being proposed in the sections, but more work is required here. So the summary, we could discuss this draft before posting with a couple of people and got valuable feedback, like, so N6 aspects are underspecified in 3GPP, so it's treated as valuable work. We should clarify that the work is on N6 and no interference with what 3GPP does is intended here. If we come up with a few extensions in terms of attributes or semantics that is required, we can make a contribution to 3GPP here. There was a comment to include the asymmetric route case, referring to this DEX slide number 3, so that should be in the draft and highlighted a little bit. Then there was a question if we should be specific to the N6 protocol, whether it should be segment routing, ILA, whatever kind of tunneling approach. So here we should be generic, in my opinion, and just treat this as a policy being enforced and under control of the control plane, which protocol is being used. There was a good point about that some data networks will apply load balancers. So this is not seen on this line N6 between the user plane function serving as the PDU session anchor and the actual server in the data network. So there are some considerations to consider, but I'm pretty sure we can easily handle that. And also, one comment was actually supporting the fact to decouple the anchor UPF deployment from the actual data networks. So more comments are, of course, valuable, but in particular, we are interested in if this is considered as useful work, complementing what 3GPP does in view of future deployment of 5G. And if you think it's useful work, we would like to get more input to update the draft with details.
Okay, thank you, Marco. So 3GPP currently doesn't recognize anything on the N6, right, on the GI. So you think that's going to change anytime soon?
Well, IETF can contribute that part here, but in strong collaboration with 3GPP.
Okay. Questions, comments?
Satoru Matsushima, SoftBank. What do you expect the function to be deployed in N6? Because nowadays, 5G architecture does have the UPF function, like policy enforcement and charging, some certain set of the function as defined already in UPF. So I don't much clear about the what functionality deployed in the N6 in the 5G architecture. Can you clarify that?
So based on the use cases, primarily we see the need to apply traffic steering policies to have the control on steering traffic to a probably relocated UPF anchor. There may be more. So if we decouple a UPF anchor from the data network and move it to the very edge, so N6 becomes very long. So we may have to apply more policies to that traffic, like MPLS labels or QS kind of treatment. So these policies also need to be enforced for downlink traffic on the data network's DPN. DPN can be a switch, can be a provider edge router. So we should not be specific here which kind of data plane node we assume here, but it needs to be programmable, and the policies come from the control plane. So there may be some basic policies which we derive from the use cases in the document, and for that we are specific, but we should be open, same as the FPC draft here.
Okay, that seems as some sort of the option. Even the 3GPP provides an interface to get the policy from an application function to control the user plane. But your option provides not to use that functionality, that the policy deploying N6 parts. Is that correct understanding?
You want me to go back to the slides?
Can you just repeat? I didn't get the last point.
So in the 5G architecture, the 5G core provides the interface to allow the application function to put the policy effect to the control to the user plane through the 5G control plane. But that policy comes from the application function. But your proposal looks a application function does control directly of the user plane.
So we just show this here using the AF, which is in the 3GPP specs, the most generic function.
Mm-hmm.
But the interface between AF and 5G core is being specified in 3GPP. So we see AF as one binding element between the 5G core and the data plane policy control. The AF may be associated with any other controller, like, for example, the MFA controller in 3-Draft or something else, right? So I'm not sure we should be specific here, but actually consider the two interfaces and work out the details here.
Okay, thank you.
Yeah, you're welcome.
John?
John from Huawei. I've talked to Marco about this quite a bit offline, and I just wanted to add that in 3GPP, most of the time, the UPF and the AF and so on are quite tightly coupled in some sense. And the architecture that Marco is exploring here is a little more loosely coupled, where there are really two domains. And then you have to have some way to exchange the policies and make sure that these two domains, I mean, each of these two domains are rich in their own interaction. They each do traffic steering and so on. But to make sure that the traffic steering that is done, for example, by 3GPP does not contradict what is done perhaps by the application domain. Just clarifying.
Yeah, Suresh Krishnan. So like, so part of this has like effect towards SA and parts of this towards CT. Is that the goal? Like, because I do see both the kind of things in the draft, right? Like, because you're trying to change some architectural stuff too. And I'll let like, you know, Georg talk if he wants, right? But I do want at least like a clear separation of like things, like the bigger things you want to change and like more like the bits you want to do. Because like the initial premise was like, this was not like clearly defined, right? So that's a different thing, because we are pretty much used quite a bit, right? Like we did like 29.275, like Sri and I were there to say, okay, for a stage 3 spec, that for something like, you know, we are kind of used to that mode of things. But changing the architecture itself, we don't like have very good track record in that, right? So I would be happier if like these two things are kind of split up, like what you want to change in the architecture versus like the protocol bits you want to change.
Maybe some more brain cycles need to go into here, but so I could say that interface between AF and a data plane and the data network, that's not covered in 3GPP. What's covered is AF to PCF, SMF kind of reference point. So that's something we want to leverage, not change, maybe extend if required. In terms of UPF, I don't think we break what 3GPP currently does, but it's definitely assuming a different kind of deployment. So if you deploy it in a different way, I'm not sure if it conflicts with the 3GPP specification of today. But if we achieve a goal, maybe that's something that can be discussed also.
Okay, Georg?
Yeah, several things on that. Well, first of all, you have to decide whether you want to have this in 3GPP or not, or that's one path to go, but that you say, well, this is something we do, and our goal is to have it in 3GPP in the end. Like 3GPP would reference it as something to be done. Or if you say, well, we do this, and if it's not appearing in a 3GPP specification, it's still a solution we are offering, right? Would be standalone. If you want to have it in 3GPP, you need your agents in 3GPP now that practically say, we require this. So you need to start from stage 1, actually. Somebody has to say there's a technical, or there's a requirement to have these functionalities. And then this trickles down to the architecture group that will maybe look at what you're proposing in this paper, but practically they will just do their study on their own, and only then the protocol groups get involved. So what we have so far with the discussion on the N9 interface, that is a replacement of an existing protocol. That is fine. There you can go directly to the protocol group and say, look at the pros and cons and so on. But what you're doing now is something completely new. And if you want that, then you really have to go strictly by the process that we have. We don't take technical solutions just for their beauty. We need really people who come and say, and put pressure on us and say, there's a requirement. So you need companies in 3GPP that push that.
So you're saying it has to come all the way from SA1, then to SA2, and then to trickle down to CT4.
Yes. So you need to have a high-level requirement from a user's or network provider's perspective that you can formulate without your language of interfaces and so on, where you practically just say there is a requirement, or there are several requirements, and those will be discussed in SA1. And that may take a time. They have their own style of working, and only then it goes down to the to the architecture group. So I think if you want that, you have to do sort of the same here. You should get clear on the requirements. You should really think of what do we want. And then before you start working on the very technical details and describing everything, you should wait on what's the outcome of the 3GPP process as well, because that is the way you can work best hand in hand. That's just a proposal. I'm not saying you have to do that, but it would sort of look natural to me.
Makes sense, absolutely.
I think that was a good comment, but I also think how much impact we have to 3GPP procedure depends on the use case, right? So the very first use case may be something that's entirely complementary, just to achieve downlink routing and to achieve the best route. Second use case was a bit more impact to 3GPP, and here I understand we should first approach SA1 with use cases, then maybe do key issues kind of description, and then make a proposal towards SA2 and CT. Yeah.
So what I said was just really like if you want to go down the 3GPP route. If you say this is something that can work standalone and you don't have 3GPP impact, that's fine. I just wanted to make clear how it should.
No, makes sense. Thanks for that feedback, Georg. Yeah. So I think, yeah, let's continue discussing this document and let's see how to proceed. Thank you, Marco. Next is Kiran on this topic. Yeah. 5G backhaul network with PR. I believe it's a new document. It's a first time presentation. Yeah. Okay.
Hello, everyone. My name is Kiran. I did not write this document. I'm representing my colleague Uma, and he presented it in IETF 102.
Just you may want to, yeah, slightly. Yeah, it's sliding down. Yeah.
Yeah, he presented this document in a rush last time at 102, and since then, what's the motivation behind it? So we talked a lot about user plane and control plane here. What we are focusing on the UPF mobility that comes in 5G network and the impact or the contribution of transport network in it. So what we are trying to solve here is we have different slice and service types. They are going to use different kind of SLA guarantees. And how are we going to provide that from the transport network perspective? So quick recap. So in order to have those kind of SSTs and SLA guarantees, we are proposing a new reference architecture in which we include a TNF, which is transport network function in the 5G architecture. This function will be responsible for distributing the TE path specific information to UPF and G node piece. And we can use the clear mapping functions to integrate PDU sessions with different TE paths. So what will happen is something like if you have 3 different type of SSTs, they will be mapped to 3 PPR IDs on each node P. So this way you can get the SLA guarantees for each type of service and slice type. So, and we don't make any changes in the user plane. If it is GTP based or whatever based, that user plane remains intact. We are only providing an underlay solution. And so in terms of SRv6, we are not focusing, it's completely orthogonal. In our case, we don't try to replace GTP layer at all. And what PPR is, that information is already being discussed in LSR. What we do is we compute the TE path at the controller level and distribute the PPR ID to the router nodes in the network. And it has resource specific information. So if you want to provide SLAs, that information is distributed and corresponding resource reservation is made on the nodes. And in comparison to SR, what we do is we reduce the overhead on the transport and all the TE characteristics are included. And we have described the table for this in the draft. in addition, this I already mentioned that for each type of SST, we will have PPR IDs. And what we have done in the document is we have described all the 3 mobility modes, SSE mode 1, 2, 3, and described how PPR ID could be used there. And these are the changes since last time. What we have done is explain more clearly how QoS is used and how it will be carried over the N3 and 9 interfaces. And there was a lack of clarity on the bearer's information that has been modified. And the clear definition of transport network function was missing. We added that now and made some minor connections. And I think we have moved some of the information from the main draft into the appendix section. So these are the next steps. Is we just want to get the feedback from the group if this kind of work should be brought in. Want to have more discussions on the mailing list as well.
Okay, thank you, Kiran. Any questions, comments?
John from Huawei. I don't have a comment about this per se, but there's some work in ACTN which is also somewhat similar to this in the sense that, I mean, not similar, but complementary, I'd say.
Yeah, so what we are actually thinking about is how ACTN and TNF function will kind of integrate or work together.
Right,
so
right.
there are
Here it's TNF and there I think it's Transport
Yeah,
Path Manager.
yeah.
And they're roughly this, but the techniques are different, but complementary.
techniques are different
But
and
complementary.
Okay, I think we are running out of time.
okay,
Thank
I'm
you.
done.
So that, okay, I think we'll discuss more this on the working in the mailer. Yeah. Okay, I think there's a new proposal. I don't believe there's a draft on this, but the authors wanted to quickly, get some feedback on what they're thinking. So yeah, okay. Yeah, 5 minutes.
Hi guys, this is Kasu from Cisco. So I want to talk about the time-sensitive network applicability for 5G. TSN as a topic, it's not something new. If you see on the wireline side, it's very mature. But with ultra low latency kind of an applications coming in, and there is a heavy dependency on the wireless. So that's where the TNS applicability to 5G is gaining a lot of traction. So even if you see the recent IEEE and ITU summary, they kind of accepted that, a lot of work to be done. So there are already drafts like IEEE 802.1 TSN, where it talks about 802.1 CM, mainly explains about the front haul standards, like how we can leverage TSN on an Ethernet kind of a Ethernet media to kind of make it more deterministic in terms of leveraged for front haul. But as part of my presentation, I'm trying to highlight some of the aspects beyond front haul. Like what are the topics we can look at for the future consideration in terms of proposing a draft. So with that, without spending much time here, this is something to see on the 5G side, ultra low latency application category is gaining a lot of traction. That's the important bucket from operators' point of view, which kind of opens up the B2B opportunities. So on the spec, like 22261, it kind of calls out the ultra low latency, the parameters, the stats. What we are talking about is like in milliseconds. We are talking about the network should be able to provide a millisecond deterministic latency. That's the ask coming in from the 3GPP specs. So if you see today, the challenges what we have is like most of the deployments are Ethernet based, and it's extremely impossible to get that kind of a latency what the ultra low latency applications are looking for. So the idea here is like it's not working.
Okay. Yeah, 2 minutes to close this because we're running out of, yeah.
Sure.
Maybe just summarize, what.
Yeah.
what
So
you want to
guys, the idea here is like, like I said, on the 5G point of view from TSN, there's already a lot of work going on in 802.1 CM in terms of how we can leverage the TSN protocol stack, on Ethernet media to kind of achieve the deterministic latency, which is kind of a prerequisite for ultra low latency kind of an applications. So the point what I want to highlight is, there's a lot of, things we have to look at from the end-to-end network slicing point of view. If you see the slicing, we are talking about an end-to-end slices. It's not about the slices on the backhaul or a packet core or telco cloud kind of thing. It should be an end-to-end. So today, if you see the work, so if you see the work here, like, this already, like, in CTN kind of a controller recommended as part of the time-sensitive networking. But there is a holistic piece missing. Like when you talk about the slices, it should be an end-to-end. And the end-to-end slices requires an orchestrator, a kind of a centralized orchestrator, which kind of integrates with the TSN controllers. So that is where, I feel there's a lot of work required in terms of defining the standards, how we can integrate multiple domain controllers that includes the TSN, as well as the deterministic networking. There's a lot of good work going on the RedNet IETF working group, like, how all these things can come together and make it an outcome in terms of, achieving an end-to-end slices and able to orchestrate the whole thing.
Okay. So, Kasu, I think we need to have two more presentations. Any final thoughts? Just
so, any comments, guys? This is a proposal. My ask is like to the team is like, if any of you guys interested to work on this, you're welcome. So we are in the process of defining the draft. This is more like a problem statements. We're working on the solutions and stuff. Maybe in the next presentation, we'll come up with a detailed draft around these problem statements.
Okay. Yeah. Thank you, Kasu. I think next time we'll give more time. Yeah. Thank you.
Thank you so much.
Time for comments?
No. Pablo. All right. Thank you.
Thank you.
This is the last presentation. Yeah.
Okay, so my name is Pablo Camarillo from Cisco. Very quickly, I'm here to present the draft SRv6 mobility use cases. Anyway. So actually, SRv6 mobility is progressing. We have the SRv6 mobile draft of this working group, which has some of the motivation behind it. We also have the 3GPP CT4 study item that is focusing on N9, and then we have some POCs going on, like the one that R. Smith presented before. But we realized that we believe that there is a lack of one single document that is documenting the motivation and applicability for SRv6 mobility. So what we did in this draft is we try to look at all the use cases where SRv6 could fit in. So we divided this into two big blocks. So the first one is it would be service provider network simplification use cases, and then the new mobility use cases. And we started trying to divide what would be the use cases for SR. So the first big item starting from the top would be the radio core handoff. So for example, can we improve how the front haul interface can we try to do a state of load or a state transfer? Can we do, well, the rip and replace GDP use case that is just simply replacing GDP with SRv6? Then we have other use cases like end-to-end network slicing, since SRv6 can cover the overlay and the underlay. Then service chaining on the N6 or potentially on the N9 interface, and ID lock isolation. Then if we look at the new mobility use cases, we have been looking at some use cases on fixed mobile convergence, on stationary IoT devices, and we will look at ultra remote, ultra reliable low latency use cases as well.
Okay, so I think quick pause, sorry. How are we doing with the blue sheets? Blue sheets, did everybody sign it? Okay, please. Yeah, thank you. Yeah, sorry.
Okay,
yeah.
So this is actually the table of content. Can you go to the next one? So this is actually a table of content, but it's what I just said. So the draft is in a very early stage. Some of the use cases are still not written there. We want to look at the ID lock isolation on the N9 interface. There has been a lot of discussion on this, and there is a draft on it, but the use case is not written. Mobile enforce SD1, Ultra, URLC. And then we also want to do further study and analysis on if SRv6 can be used to optimize the N4 interface and the security implications and benefits. So just what we would like to do right now, since this document is very early stage, is just to call for participation from people in this group. We believe there are many use cases. There will be use cases where, of course, SRv6 will not fit, and we want to identify these too. And we just welcome anyone to join this draft if they want, or just to provide feedback.
Okay, thank you, Pablo. Any quick questions?
I've got a number of comments which I can probably post
Just
to.
quick,
Yeah,
yeah.
I'll make it quick. I think there's a minor thing. Is this draft intended to be a standards draft? I mean, standards track, maybe not. I mean, I don't know. But
No.
that's what it's marked as. But
Okay,
okay,
we will
two-
change it.
Oh, yeah, that's fine. So two broad comments I'm getting from my CT4 guys as well is that in many places in the draft, it looks like it's going to change the 3GPP control plane. Sometimes it looks like it's going to be only 23501 base, but then at other places it say that the path, the head end is going to do a lot of things. Same thing about the state. And it says that it can reduce state, but if you got to reduce state, you got to change the 3GPP control plane because that's what's holding all the state. So there are lots of other detailed comments about like hairpinning and other things which I can post to it.
So, John, can you post those comments
yeah,
into the
yeah,
mailer,
I've got
please?
it.
Yeah.
I'll do it.
So just to reply in short, so in essence, there will be some of the use cases that might require to change the 3GPP architecture. But what we are trying to do here is to identify the use cases. We are not trying to propose this as a standard. It's just to identify the use cases. Some of the use cases will be suitable for SRv6, some not. And then based on it, we can evolve on the SRv6 mobile user plane.
That's fine. I think, I guess the only request is to separate those two so that it can be seen what is modifying what. At this point, it's very confusing if you read.
Okay.
The draft
That's
is
okay.
early stage.
Yeah.
If anyone wants to
Thanks
join.
everyone. With that, thank you, Pablo. We close the meeting. Thanks everyone. Yeah. Hey, Danny. There was some discussion on that, but no, I talked to him actually. I think that's what. In general, there's some concern, but I think this one I'm sure that you have to be super sensitive because this is not your fault, right? This is not your fault. Because there's a lot of history and this one is also mistakes. So we try the points.